Hi class, let's take a look at example 4. Now example 4, it's a little bit confusing because the way that the author expressed the y values, notice that all of these are positive for your y's, and then technically these will be our x's. Okay, so let me write the domain. And for the domain, we're looking at, well, values from 2 to 6, and we're including those two, so 2 to 6. The range, we're going to be including, well, from 2 to 6. And then, as you can see on this one, the graph is going to fill the horizontal line test. So let me just insert that one. Okay, remember that you just need to show on the graph that there are 2 points where the graph technically is intersecting, or in this case, a horizontal line. And you can see that these occurred at those 2. So let me just write it in terms of the 1-to-1. And in this case, no, the function is not 1-to-1 because it fails the horizontal line test. And that's actually it for this one. As I mentioned earlier, it's a little bit confusing. These look like they should be negative, but no, they're all positive values. It's just a different way that the graph was expressed. Let me take another look. Once again, domain 2 to 6, range 2 to 6 as well. No holes on the graph between 2 to 6. So we're going to be including, well, those 2 edges. Let's take a look at problem 5. In problem 5, we're going to be doing a little bit of an estimate. On the good news, this particular one, well, we do have the axes where they're supposed to be at in terms of the numerical values. So these are going to be your x's, and these will be our y's. Okay, so for the domain, I would say that in the negatives, about 2.5. So definitely negative 2.5 towards. And technically notice that it looks like it stops here, but your actual curve increases. So that means it goes all the way to the positive infinity. The range, it's going to start at -4 bracket and then all the way to the positive infinity. And then once again, your x's or your domain from -2.5 all the way to the positive infinity. The range from -4 towards the positive infinity. For the portion of the 1-to-1, this one is going to fail as well. And you only need 2 coordinate points for to show that it's not 1-to-1. So give me just a second. In this one, well, notice that you can actually find more. So for the 1-to-1, only 2 values are sufficient to show that it's not 1-to-1. This one, you can actually, if you place it here, your horizontal line, we can find more than 2. So you would say on the 1-to-1 portion that no. The function is not one-to-one. Since it fails the horizontal line test. And that's it. You could have a problem that they're asking for the coordinate points. In this case, you would find plenty of coordinate points where the horizontal line intersects. You could just pick negative 1.5 and negative 4. You'll see the two y's matching, and that's all it's sufficient. That's it for these problems.